Hello students, welcome to our tube education. Today we will solve the question 5, 6 and 7 of exercise 13.1. I am Bilkis of your maths teacher. If you support my tube education, then like, share and subscribe my channel and don't forget to hit the bell icon to get latest notification. So at first question number 5. A hemispherical depression is cut out from one face of a cubical wooden block such that the diameter L of the hemisphere is equal to the edge of the cube. Determine the surface area of the remaining solid. So at first clear the concept very well. Suppose question number 5. Suppose this is a cubical block. Now a hemisphere is cut out. They had told us a hemisphere is cut out from inside this box. A hemisphere is cut out. That means like that. A hemisphere is cut out from inside this box. Where diameter of this hemisphere is equal to edge of the cube. Now you have to find out the surface area of this remaining portion. You have to find out this surface area. So how to find it? What are you thinking, students? You will just remove the area of this hemisphere and you will get the remaining portion, area of this remaining portion. But it's wrong. Because you have to find out surface area, not volume. Surface area means area of the surface. So after cutting this hemisphere, what surfaces do you have? After cutting this hemisphere, what surfaces do you have? Like that, after cutting this hemisphere, this surface plus this surface is formed, this new surface here. This new surface is formed. So you have to add the area of this surface. So it can be observed that radius of the hemisphere given hemisphere is equal to L by 2 because diameter is L, so radius L upon 2. Now total surface area of remaining solid, total surface area of remaining solid is equal to total surface area of remaining solid is equal to surface or area of this cubical part, surface area of cubical part minus area of this circle, this upper circle, because this portion is removed. So minus area of this upper circle, area of upper circle plus curved surface area of this hemisphere. curved surface area of hemisphere. That means surface area of cubical part, that means 6L square, minus area of this upper circle pi r square. R means L upon 2 plus curved surface area of this hemisphere. Curved surface area of this hemisphere, that means 2 pi r square. R means L by 2 whole square. That means 6L square minus pi L square by 4 plus 2 into pi L square by 4 is equal to 6L square minus plus 2 pi L square by 4 minus pi L square by 4. That means 1 pi L square by 4. Now taking common L square by 4. That means 24. 4 6 are 24 plus pi is equal to 1 by 4. 24 plus pi into L square. So that's the answer. 1 by 4 into 24 plus pi into L square. Now the next question, question number 6. A medicine capsule is in the shape of cylindrical with two hemispheres stuck to each of its ends. The length of the entire capsule is 14 millimeter and diameter of the capsule is 5 millimeter. Find its surface area. So next question, question number 6. So they had told us our medicine capsule is in the shape of cylinder. That means like that. A cylinder. Two hemispheres stuck to each of its ends. Two hemispheres stuck to each of its ends. And given that the length of the entire capsule. Length of this entire capsule 14 millimeter. And the diameter of this capsule. This diameter of this capsule, that means this length is equal to 5 mm. You have to find the area of this capsule. So here surface area of this capsule means surface area of this capsule means surface area of this hemisphere plus surface area of this cylinder plus surface area of this hemisphere. Here only curved surface area, not total surface area, because this portion is not here. So only this side, this side. So here curved surface area of them. So by the given condition, length of the at first radius of this hemisphere, radius of the given hemisphere is equal to diameter 5. So radius 5 upon 2 millimeter. Now length of this cylinder, length of the cylinder is equal to or cylindrical part. You can also write length of the cylindrical part. This is hemispherical part is equal to total 14 minus this length, that means 2 times of radius is equal to 14 minus 5, that means 9 mm. So this is the length of this cylindrical part. So now the required surface area. Required surface area is equal to surface area, curved surface area, not total, curved surface area of cylindrical part plus 2 into curved surface area of this hemispherical part, because this is 2 times. So plus 2 into curved surface area of hemispherical part is equal to curved surface area of cylindrical part, that means 2 pi RH, 2 pi RH plus hemispherical part, that means 2 into 2 pi r square. Now just put the value. 2 pi RH plus 4 pi r square. At first taking common 2 pi r. That means 2 pi r h plus 2 r. Now put the value. 2 into 22 upon 7. R means 5 upon 2. H means 9. Height of the cylinder 9 plus 2 into 5 upon 2. Now calculate this value. 2 cancel out. 22 upon 7 into 5 into 2 cancel out. 9 plus 5, that means 14. 7 2s are 14. That means 5 2s are 10. 220 mm square. That's the required answer. So that means surface area of this total medicine capsule is 220 mm square, millimeter square. Now next question number 7. A tent is in the shape of a cylinder surmounted by a conical top. If the height and diameter of the cylindrical part are 2.1 meter and 4 meter respectively, and slant height of the top is 2.8 meter, find the area of the canvas used for making the tent. Also find the cost of the canvas of the tent at the rate of 500 per meter square. So here the given condition is question number 7. Given condition is they had told us a tent of shape of cylindrical, like that, cylindrical, surmounted by a conical top, surmounted by a conical top, like that, and given that the diameter and height and diameter of this cylindrical part, this is 2.1 meter and diameter 4 meter. This diameter is equal to 4 meter, and given that the slant height, this slant height L is equal to 2.8 meter. Now you have to find that the area of canvas used for making this tent. So for making this tent, which place should be covered with canvas? This two place and this place plus this place. Because note that the base of the tent will not be covered with canvas. Given that this base of this tent will not be covered with canvas, So for making this tent, which place should be covered with canvas? Curved surface area of this conical part plus curved surface area of this cylindrical part. So by the given condition, by the given condition, height of the cylindrical part is equal to 2.8 meter and radius of the cylindrical part is equal to 4 by 2, that means 2 meter, and slant height of conical part is equal to 2.8 meter. So now the required area, that means the area of the canvas, required area of the canvas is equal to curved surface area of this conical part, curved surface area of the conical part plus curved surface area of cylindrical part. Cylindrical part. So curved surface area of conical part, that means pi RL, and curved surface area of cylindrical part, that means 2 pi RH. Now taking common pi R, that means L plus 2H. Now put the value. Pi means 22 upon 7, R means 2, L means 2.8, 2 into height means 2.1. That means 22 by 7 into 2 into 2.8 plus 4.2. Now this is equal to 22 upon 7 into 2 into 2.8 plus 4.2, that means 7. So 7 cancel out, that means 44 meter square. That's the required area of the canvas. Now the second part. Also find the cost of the canvas of the tent at the rate of 500 per meter square. That means cost of 1 meter square canvas. That means cost of 1 meter square canvas is equal to rupees 500. So cost of 44 meter square canvas is equal to 44 into 500, that means 22 rupees, 22,000 rupees. That's the answer. Thank you.